Okay, so today we are looking at subtracting mixed numbers. Now, some subtracting mixed numbers problems are pretty straightforward. For example, if you had the problem 2 3/8, 2 3/8, and you were taking away 1 2/8, you could just do 3/8, take away 2/8, that's 1/8. 2 take away 1 is 1. And you get 1 1/8. Pretty straightforward. Some are not so straightforward. So, for example, if you are doing the problem 2 1/8, take away 1 3/8. Notice I just changed where the 3/8 part was. I flip-flop. Now you've got a problem. Now you've got a problem because you're trying to take 3/8 away from 1/8. These are the ones that leave us going, how do I take 3/8 away from 1/8? So that's what we're going to look at in today's video. One quick thing before we get there, I want to show you a way of checking your work as we go along, and it's based on this very simple idea that you've done with subtraction all your life. So if you take a basic subtraction problem, let's take 10 minus 6. 10 minus 6 going to give you 4. After you do it, if you take these two numbers and add them together, the 10 and the 4, or excuse me, the 6 and the 4, take the 6 plus the 4, you get the 10. This works with every subtraction problem out there. If you had 15, take away 7, that's going to give you 8. If you take the 8, so I'm taking these two numbers. If I take the 8 and the 7, if I take the 8 and the 7 and I add them back together, I get the 15. So you can always check a subtraction problem by taking the answer, adding it to the number that you were subtracting, the amount you were taking away, and what you'll get left over is the amount you started with. So we're going to do that on each of our problems as a way of checking our work. All right, so let's jump to it. So we're going to be doing this using a rectangle model. And what the rectangle model does is it allows us to visualize what's going on. So if you look at this first problem, we have 4, and we're taking away 1 1/4. So let's shade 4 of these in. Let's shade in 4 of our rectangles. All right, so we've got our 4. We're taking away 1 1/4. The problem is there are no fourths here. There are no fourths to take away. So we need to create some fourths. And what we're going to do is we're going to take one of these rectangles and we're going to divide it into fourths. So now, if you look at what we have 1, we have 2, we have 3, 1, 2, 3, and 1, 2, 3, 4 fourths. So we're going to rewrite our number as 3 and 4 fourths. Now we're going to take away 1 and 1/4. Well, now we've got all the fourths we need. 4 fourths, take away 1/4 is 3 fourths, and 3 take away 1 is 2. All right, so we took away, let me just show you what we took away. We took away 1, there's the 1 we took away, and we took away 1/4. So we were left with these 2 and 1, 2, 3 fourths. Now I told you we're going to check our work each time by doing the addition, by adding back. So we're going to take the 2 and 3 fourths that we ended up with. We're going to add back the 1 and 1/4 we took away. We're going to get 3 fourths plus 1/4 is 4 fourths. 2 plus 1 is 3. This is the same as 1 whole. We can bring our 3 down, and now we have 3 plus 1 equals 4. And that is exactly what we started with. And so we know we did it right. So our final answer on this problem for 4 and 1/4, or excuse me, 4, take away 1 and 1/4 is 2 and 3/4. Okay, let's take a look at the next one. So we've got 2 and 1/3, and we're taking away 1 and 2/3. Well, we can see a problem here. We're trying to take away 2/3 when we only have 1/3. So again, let's start by shading what we have. We have 2 and 1/3. I'm going to need to take a box here and divide it into thirds so I can get one of those thirds. All right, so there are my 2 and 1/3. Now, my problem is I'm trying to take away 1 and 2/3. I don't have enough thirds. So what I'm going to need to do is I'm going to need to take another box here and divide it into thirds. Let me get a darker color there. So I still have 1, 2, and 1/3, but I've rewritten it. I've given it a different name. This is called renaming. And what I've done in this case is I've renamed my 2 and 1/3 into 1 and 4/3. Trying to get a 4 there. There we go. So really that's what you're seeing now. You're seeing 1 and 1, 2, 3, 4/3. So now I can take my 1 and 4/3 and I can subtract 1 and 2/3. And what I get are 2/3 here, 4/3, take away 2/3 is 2/3, 1 take away 1 is 0. I get 2/3 as my answer. That's what I am saying the correct answer is. Let's double check it. We're going to take that 2/3 and we are going to add the 1 and 1/3 that was being subtracted. And we're going to get 2/3 plus 2/3 are 4/3 and 1. And you'll notice we are back to, let me circle that, we are back to this answer, which we said was equal to our 2 and 1/3. So we've proven that our answer 2/3 is correct. All right, let's take a look at another one. Now this problem, there's a slight little thing we have to do ahead of time. On this problem, you will notice that we have unlike denominators. Those are not the same. And we know that any adding or subtracting problem with fractions or mixed numbers, the denominators have to be alike. So let me get rid of those. So we're going to get common denominators. Now, as it turns out, common denominator here is the 6. 2 can go into the 6. So we're just going to rewrite these. And you've had a lot of rewriting practice. We're going to rewrite this as 3 and 3/6 instead of 1/2, because we know that, here's what we know. Let me get some room to write here. Here's what we know. We know that 1/2, if you're changing it into sixths, well, 2 times 3 makes 6, so 1 times 3 makes 3. Now we're going to take away our 2 and 5/6. Again, you can see our problem brewing here. Again, we're trying to take away more sixths than we have. So let's start, though. Each time we're going to start by just shading what we have. So this tells us we have 3, 1, 2, 3 holes. That's the 3 holes. And then 3/6. So I need 6. I'll tell you the way I find easiest to make 6 so they're not little tiny pieces is I make thirds and then I cut those thirds in half. Now you can make them by going 3 straight down, another 3 down if you want to make 6. But I like this because it gives me something a little bigger to work with. And I need to shade 3 of those. So I'm going to shade these bottom 3. I didn't shade this way just because I like seeing that I still have a half. Remember, my original number was 3.5. So I can still see I've got half of that shaded. Okay, but here's my problem. I'm trying to take away 2 and 5/6. I don't have enough sixths here. I only have 3. So I'm going to create some more 6. I'm going to rename this box into sixth also. So really what I've drawn for myself now, when I look at my rectangles, I have written my rectangles as 2. Here's 1, here's 2, 1 and 2, 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 6th. Now that's enough 6 to take away the 2 and 5 6th. And I didn't do it. I'm going to jump back to the last problem just because I realized I forgot to show the crossing out. I got so excited by my work. So I had to take away the 1 and 2/3 over here. So there was the 1, and there were 2/3, 1/3, 2/3, and I had those 2/3 left. I'm going to do the same thing over here. I'm taking away 2 and 5 6th. I'm taking away 1, 2, and I'm taking away 5 of the 6th. So there's 1, 2, 3, 4, and 5. And what I have left over right here are 4 6ths. Well, if I do my work up here, that's exactly what I'm going to see. I'm going to see that 9 6 take away 5 6 is 4 6. 2 take away 2 is nothing. I've got an answer of 4 6ths, which I can simplify to 2/3. There's my answer right there, 2/3. Now, once again, I'm going to check my work. I'm going to take that 2/3 that I had left. Actually, you know what? I think I'll leave it as 4 6ths. It'll be easier to do the work there if I leave the common denominator. I'm going to take the 4 6ths that I had left. I'm going to add the 2 and 5 6 that we were taking away. I'm going to end up with 2 and 9 6ths, and that 2 and 9 6ths is exactly what I started with after I renamed my problem. But we know that was the same as this. We know this amount was the same as that amount. So again, we know we did the problem correctly. Always use that addition at the end to make sure you've done the problem correctly. Okay, let's go ahead, flip your paper over, and we're going to do these problems on the back. Now, for these problems, what I'm going to recommend you do is go ahead and do either just 4 and then listen to the video, or if you're feeling pretty confident, do 4, 5, and 6, listen to the video. Remember, you don't have to watch it step by step. You don't have to listen to the beautiful sound of my voice the whole time. I don't like to hear my voice that much. You can just fast forward to the answers. That's the great thing about doing this with video. However, if you, let's say you did 4, 5, and 6, and you fast forward to the end of 4 and you get it wrong, don't just fast forward to the end of 5. Recheck your work on 5. Make sure, did I do this correctly? What did I miss on 4? Go back on 4, listen to the step by step, and then check 5 before you decide to move on. Okay? So go ahead, pause the video, and give yourself a chance to solve these problems. Okay, well, let's take a look at number 4. So first thing I'm going to do before I go any further is I'm going to figure out on number 4, what's my common denominator going to be? That should always be your first step. It's find that common denominator. Well, in this case, it's going to be 8. Both of these can go into 8. So we're going to start out by just rewriting the problem. 4 and 2/8 take away 2 and 5/8. That's step 1 of our problem here. Now, as soon as we do that, we can see that we've got a problem. We're trying to take, I was trying to fix my 2 there, and I only made it worse. Let's see if I can make a better 2. There we go. We're trying to take 5/8 away from 2/8. We can see that that's going to be an issue. So we know we're going to rename something. So step 1, let's get our 4 and 2/8 shaded in. And you'll notice I pick a kind of a lightish gray color. when you do yours, just take your pencil and lightly shade. You don't want to make it so dark that you can't see your lines later. So 4 and 2/8. I'm going to need this in eighths. And kind of like I did sixths, I find the easiest way to do eighths is to make fourths and then put a line across to get eighths. And I am going to shade 2 of those. Yeah, I don't like that. Shade them individually so I still see my black line. Perfect. All right, so now I've got 1, 2, 3, 4, and 2/8. However, there's a problem here. If I think of it as 4 and 2/8, there are not enough eighths there to take away 2 and 5/8. Don't have enough eighths. So I'm going to need to rename the 4. Instead of having 1, 2, 3, 4, I'm going to rename the 4 by changing this into eighths. Now notice I've got 3 now. So I renamed it 3, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 eighths. Now I've got plenty of eighths to take away 2 and 5/8. 10/8 take away 5/8 are 5/8. So I took away 5/8. 1, 2, 3, 4, 5, and I had 5/8 left. And now I'm going to take away the 2. Take away the 2. And I've got 1 left. See, the whole idea of this rectangle thing is to give you a visual interpretation of what this looks like. So I've got 1 and 5/8, 1 and 1, 2, 3, 4, 5/8. Seems right. Yep. Let's double check it with our addition. So I'm going to take that 1 and 5/8 that I had left over, and I'm going to add the 2 and 5/8 that I subtracted. And I'm going to get 3 and 10/8, which is exactly what I had up on top. And that is equal to, we said before, the 4 and 2/8, which was equal to the 4 and 1/4. So we can feel confident about this answer, because when we look at this answer, it matches what we started with, 4 and 1/4, which we said was 4 and 2/8. There you go. So now you've seen problem 4. If you got that answer right, if you got 1 and 5/8 and you already did 5 and 6, fast forward to the end of the part 5, check your answer. If you didn't get 4 right, if you did not get 1 and 5/8, then before you look at the answer for 5, check your work on 5. You're going to learn a lot more about this if you fix your mistakes as opposed to you just go with your mistakes and watch me talk about how to do it correctly. That you don't learn nearly as much that way. All right, so make your decision whether you're going to continue the video or whether you're going to pause the video to go back and rework 5. Or maybe you haven't done 5 yet at all, but now you're feeling super confident. Go ahead and do 5. Okay, we're ready to do problem number 5. Now I'm going to go back up to the top of my screen here for just a minute, because now we're getting into some unlike denominators where they don't just one go into the other. Like here, 4 went into 8. So just a quick reminder, when you've got a problem like 1/4 and 2/3, the whole number part we never worry about. That's 3 is going to be 3. But the 1/4 and the 2/3, you might want to just jump up here. 1/4 equals something, and 2/3 equals something. What do they both go into? Well, in this case, they both go into 12. 4 times what makes 12? 4 times 3. So we've got to do 1 times 3. We get 3/12. 3 times what makes 12? 3 times 4. So how much is 2 times 4? Well, 2 times 4 is 8/12. All right, great. So now I can rewrite my problem 3 and, instead of 1/4, 3/12 minus 2, and instead of 2/3, 8/12. And we can see again, we're trying to take too many 12ths away, trying to take away more 12ths than we have. But we know how to solve that now. We know how to rename. So let's start out and shade in. There's 1, 2, 3, and we need 3/12. So 12ths, again, I find the easiest way, get the 4ths, and then divide up the 4ths, and that ends up giving you 12ths, and we need 3 of those. And notice, when I shade them that way, you can see the original 1/4 that we had. Originally, the problem was 3 and 1/4. Well, you can see the 3 and 1/4 out of this. All right, we're trying to take away 2 and 8/12. We only have 3/12. It's time to rename. I wish I had some cool music that was like, da 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 da, rename. Maybe one of you who's more talented than I am at this. Delay. Hey, Delay. You can come up with some cool music for me. I'll use it in future rename videos. All right. So we renamed. Now we have 1, 2. So now we have, when we renamed, let's put it up here. We had 3. Let me get that 3 a little bit bigger. We had 3 and 3/12. And we have renamed it into 1, 2, and, so into 2 and 12, 13, 14, 15, 12. That's the rename game. We're taking away 2 and 8/12. Now we have enough 12s. Before we were trying to take away 8/12 from 3/12. Not enough 12s. We needed more 12s. Now we got plenty of 12s. Now we can do 15. Take away 8 is 7. So we have 7/12. And the 2, take away the 2, gives us 0. So let's look at what I just did there. I took away 8/12 first. So I took away 1, 2, 3, 4, 5, 6, 7, 8/12. And I took away 2. 1, 2. And what's left are 1, 2, 3, 4, 5, 6, 7/12. Look at that. Ta-da. 7/12. Okay? Double checking work. We're going to make it a point to always check this. It only takes a minute, maybe 2 minutes to check it, but that 2 minutes can be the difference between doing it right or realizing, oh, shoot, I messed that up. Oh, there was my simple mistake. So we're going to take the 7/12. We're going to add back the 2 and 8/12. We are going to get 2 and 15/12. And we said earlier 2 and 15/12 was equal to the 3 and 3/12, which was our common denominator form right there for the 3 and 1/4. So we know we did it right. We can be confident with the 7/12. Okay, same message on number 6. If you've been right on 4 and 5, fast forward to the answer on 6. If you haven't been right on 4 or 5, pause the video, redo your work on 6, or at least check your work. You don't have to redo it. I'm not saying erase it all and do it over. I'm saying check it, double check it against what we just did to make sure that you feel confident. And then pop the video back on. Okay, let's take a look at number 6. So in number 6, the first thing we need our common denominators. So we can look here and see that we've got 4 and 6. Those are going to be 12ths. So this is going to be something in 12ths, and this is going to be something in 12ths. Well, 3/4, 4 times 3 makes 12, so 3 times 3 makes 9. 6 times 2 makes 12, so 5 times 2 makes 10. So I've got 4 and 9/12, and I'm taking away 3 and 10/12. Again, you can see we're trying to take away more 12ths than we actually have. So we're going to have to do some renaming. But first, let's do some shading. Let us get these 4 and 9/12 shaded in. So we're going to have 1, 2, 3, 4, and 9/12. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9/12. All right. So there's my original 4 and 9/12. Now my problem is I have to try to take away 3 and 10/12. I don't have 10/12 to take away, so I need to rename. So right now I've got 1, 1, 1, 1, 9/12. But I need more 12ths. So I'm going to need to rename this. I'm going to need to take this and divide it into 12ths. So instead of 1, I'm going to be thinking about that as 12/12. So now what I have is I have 3, 1, 2, 3, and 21/12. Put 12/12 with 9/12, you get 21/12. Now I have enough. I can take away 3 and 10/12. 21 take away 10 is going to be 11. I started to write a 9 there, but I meant to write an 11. That's going to be 11/12. Let me actually do that takeaway. I got to take away 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that leaves me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I'm going to take away my 3. And I end up with an answer of 11/12. All right, let's do our addition. Remember, we said we were going to do addition at the end to make sure we did it correctly. So we're going to take our 11/12. We're going to add it to what we took away, which was 3 and 10/12. We're going to get 3 and 21/12. Look at, there it is right there, which we know is the same as 4 and 9/12. And that 4 and 9/12 is exactly what we had when we did our common denominator mixed number at the beginning of this problem. All right, so there you go. That is how you do subtracting mixed numbers when you need to borrow some or rename. Renaming is the term we use. Okay, we're going to open your textbook now, your consumable book. So would you pop that open, please? Because we're going to do a couple problems to have you check yourself. Okay, turn to page 302. We're going to do a couple problems here on page 302. And what I'd like you to do is I'd like you to do problem 2 and problem 3. So 2 is going to be straightforward because you already have enough 6. But 3, you're going to have to do the renaming part. So go ahead, do 2 and 3, and then turn the video back on and we'll talk about those. Alrighty, problem number 2. So here we already have enough 6. And let's set this problem up. These are easier to solve, I find, if you put them in this form. Because now we can see we're taking 5/6 and we're subtracting 1/6 from it. That gives us 4/6. 7 take away 3 is 4. Simplify this, and you should have had 4 2/3 as your answer. Hopefully, that's what you got. All right, now, number 3. This is the one that's actually going to cause us to have to rename. So we have 11, and we're taking away 6 3/8. But you can see there are no eighths in this problem, in this 11. So we're going to do this up here. So take that 11, and you're going to rewrite it. Think about what you need to rewrite the 11 as. How do you need to rewrite it so there are eighths to take away? Well, if you were doing the rectangles, you would know that you have to take one of these and turn it into 8/8. So we're going to have 10 and 8/8. Now we can take away the 6 3/8. Now we have enough eighths. That's a terrible looking 8. Come on, pen. There we go. Now we have enough eighths. 8/8 take away 3/8 is 5/8. 10 take away 6 is 4. And that should have been your answer, 4 5/8. Okay, so that's your lesson in how you do subtracting, where you have to rename things. There's going to be a chance to practice. There are some more problems in this lesson in your consumable textbook, and you'll have a chance to work on some of those in class or as homework. Actually, you're going to work on them as homework, and we'll discuss them in class. Okay, good job. And thanks for watching.